the hackerspace. What is IoT? Today, IoT is anything that is kind of smart. So any appliance that you can buy for home, like I don't know, light bulb or refrigerator, whatever, that has some kind of chip inside of it that you can interact with from your phone or from some applications online, and that this interaction goes through the internet. So if you have any questions during my presentation, raise a hand. So today, most of those appliances are, I'm going to talk about home, but you also have appliances that are IoT stuff that are for companies and not necessarily home. So critical infrastructure also has controllers that are managed remotely and that are connected to the internet. And as you can see, more and more stuff are connected, and those connections are going through probably your home router. So the internet speed of it comes in handy when you have more devices. Okay, intuitive. Yeah. Okay. Many of those devices that we use today are cheap, and this pricing is really the drive that makes these technologies insecure, because many of the companies and startups that are making IoT stuff tend to make them as fast as possible, as many as possible, and as cheap as possible, so they can reach the wide range of people who are be able to afford them. So this means that they are compromising on security, because security of the IoT means that you need engineer, you need some software, you need time testing it uh, for vulnerabilities, for bugs, and the updates of those IoTs once they come to your home is also questionable. Once you buy something that is IoT, you basically never think about updating those software. You just put it and it runs, and while it works, you just leave it alone. So mm biggest flaw here is this fix, and that's why hackers are mostly counting on, and they are exploiting it. Maybe you heard about Shodan. Shodan is a search engine for not just the IoT stuff, but everything that's exposed on the internet. And they have search engine where you can search for, I don't know, cameras. That's most popular, and you can find cameras that are in your neighborhood or somewhere remotely. I don't know, Japan, I don't know, Turkey, whatever, and you can find all sorts of information about that connected devices. Like if we are speaking about cameras, you can find out Shodan what kind of firmware are they running, what kind of software versions, uh, is there any vulnerabilities related to those software. You can easily find all of this information from search engines like Shodan. But it's not only Shodan. Today we have a couple of more competitors in that space. So the information about insecure online IoT devices is available today to everyone. Just few clicks, and you can find anything. You can easily find if your neighbor is running what kind of fridge if it's connected to the internet via IoT. So another negative stuff is that we don't have today many of the IoT security solutions. So if you go online and see what can you do for your IoT stuff at home, how can you secure them more? Is there some kind of company that is offering some kind of service or some kind of software for it? There is no. There's a couple of companies, but you probably not gonna use them because those companies are making their products for other companies, not home use. And the positive stuff is that the code that you're developing for IoT is very small. So if you are a hobbyist and you have a couple of other friends who are in security and know how to audit code, then you can ask them just to spend a few hours or days, try to test your code, find the vulnerabilities before you publish some stuff on GitHub and make it production ready. So easy to audit. Some of the software that we are using now, like Chrome browser or I don't know, Windows operating system, they have huge code base. So auditing those stuff is very hard, expensive, and takes many, many years. And when it's done, it's not 100%. They millions of lines of code. You cannot possibly see what is related to what situation can there be that you're not predicting. So the one of the biggest attacks in IoT is that attackers are finding those devices and then using them to manipulate them to go to some other resource and try attacking them with the requests. So this is the this is denial of service or dedicated denial of service, depending on how much of these devices are taken over by hackers. So once the hackers identify a vulnerable device, they'll try to find where else they can find the same device that they can hack. So for example, if they find some kind of vendor for a camera that has vulnerable software or firmware installed in it, they will try to find where else on the world is the same software also running. And once they identify them, they can also attack and hack all of those devices and instruct them to do whatever they want. So this is where they set up a command and control server. Command and control server acts like a server that it's telling those cameras what to do. In this example, there are cameras, but it can be whatever. And once the attacker tries to do for political reasons or whatever, he can knock out popular sites, and that's exactly what happened in the famous Mirai botnet attack. This is one of the largest at that point, and it really showed us what those small devices with internet connection can do when there are a lot of them controlled by a single threat actor. So Mirai botnet was actually pretty easy for hackers because they only needed to find out the default username and password for the device. So anyone who had cameras and DVRs of specific vendors and they didn't change those usernames and passwords, hackers easily identified within minutes on the internet when you connected those devices online and immediately taking them over. And they attacked some of the well-known hosting companies like OVH, and they've taken out so many stuff that's on those hosting services. So hosting services are renting their servers, and you can have your own site there. So if you were on their servers, then this attack could disrupt you. But the scale of this is 1 terabyte per second. This is really, especially for 2016, really hard to defend against. And 600,000 devices is really not that small number. And for example, in Europe, the number of the IoT devices per person is like 2 or 3. But in America and Asia, this number is between 4 and 5. So, and growing. So this security is actually what we'll have to think about more seriously in near future for sure. Some of the popular websites were also down and unavailable in certain regions because of this attack, like Twitter, Netflix, Airbnb, Reddit, something that all of us actually use. And other stuff is ransomware. This is not that popular in IoT world, but it can also be affected because if you have some device that has some data on it that you rely on for functionality of this IoT device, that ransomware can disrupt it. But if you don't, you can just plug out and plug in, or turn off and turn on again device, and it will work pretty well again. Just in going back to Mirai, if you were attacked by Mirai botnet at 2006, all you had to do is to turn off the device, change the password, turn it back on, and it will be secure. There's nothing they could do. They didn't find vulnerability in the firmware. They just figure out the default username and password. That's all. So yeah, ransomware. Ransomware is more for devices that you use every day, like your phone. If you have servers or laptops, home computers, if you're gaming, that can be very disruptive. That happens to you. But for IoT, that's not that serious because they have chips that are going to default state to work if they are impacted. So not that for IoT something that you should worry about. Another thing is this is a ransomware attack that attacked uh, phone device. So from phone device, virus then try to see if you're connecting your phone to the smart TV. And once it saw the smart TV connected to your phone, it went to the smart TV and encrypted data on the drawing smart TV. So this can be actually something that you don't want to happen, but you can easily reset this to default and go back. This is just inconvenience because you maybe have some channels set up in order in certain way that you'll need to spend hour maybe setting them back on. But those attacks are all now 10 years old. So we can see that these vulnerabilities in IoT are not going anywhere. Uh, another security concern for IoT device is espionage, and this is also concern for the European Union and some countries in Europe that ban the toys that have that are connected to the internet and have speakers and microphones. This is the famous case of my friend Kyla, and my friend Kyla was actually banned in Germany in 2017 because of these vulnerabilities. Hackers demonstrated that they can hack them over the internet and over the Bluetooth to serve ads and inappropriate content to the doll. Doll can also speak because children could ask something to the doll, and doll can answer based on data the doll finds online. So hackers can manipulate that to speak profanity or stuff like that, or loud noises to children, uh, and that is major concern. So there is a good TED talk if you're interested in that. You can see TED talk Spies and Dolls, the future of IoT security. Is I think that's the talk from 2018 or something like that. Yeah, couple of articles about that if you're interested. But that's basically what's happening. Trying to maybe European Union maybe try to regulate how secure your firmware or software on those IoT devices, especially for children. Another concern is that for espionage, as I said. So if you're some kind of senator or something in the government important, and you buy your children some of those toys that are IoT and connected to the internet, and go home and speak to your wife about something that's maybe confidential. And if hackers can hack your doll, then they can, through the doll, hear about your conversation. So another aspects of privacy. And there are some also solutions. First of the solution is this update stuff. So proposed solution for now is this firmware update over the air. So that means that once you connect your device and set it up, you don't need to care about this update. It will be done automatically by the device and the vendor that produced the device and the software. So you connect it, and the vendor updates it whether you like it or not. So they're pushing updates to hundreds and thousands of their devices when they have it. And that's nothing that you can do about it because you need to connect it to the internet. So once it's connected, it's going to get the update by its own. You can read more about it if you're interested in that. But that's something that's not implemented yet in all of the IoT devices, but it's one of the solutions because the update is most critical, and end users in most cases don't know how to update manually their IoT devices. It's not for average user, and sometimes it requires some of the hacking skills. And the other alternative is also open source, because we are supporting open source. I think Limaicro has a lot of open source hardware in it. Yeah. So that's another alternative, because if you don't trust some other vendors from China or some other country, you can use open source stuff and build your own code, compile your own code, and test your own device how it works, and update it when you want, how you want. It should be a viable alternative. And another thing is, this is actually my kind of area, because I'm not that in IoT, but security. So this is how you can secure your own IoT devices and network at home using open source software and open source firmware. One of the devices that you all have home is ISP router. So you probably have Wi-Fi on it and devices are connected directly. Because there is no so much solution for this ISP router, my solution is to buy another router that I can flash some open source firmware on it, and then make it do something that ISP's router cannot. And one of those things is installing and monitoring connections and implementing firewall rules and security inspections of the traffic going in and out, and also separating the networks from my devices that I trust and separating the network of the IoT device. So in case some of the IoT devices get infected, they cannot spread that infection and ransomware to my other devices that I trust. One of the solutions that here is implemented is OpenWRT. You can all see, and there is on their website, there is a list of supported devices. So not all devices are supported, but if you have popular device like Raspberry Pi, you can use that for sure for building your own home secure net. I'll just talk about some of the other open source security software that can be used and how it can be used and applied, and technologies that they implement to secure the network. So one of the things that you can do, if you have maybe if you have older laptops and some old hardware at home PC stuff, you can turn it into a router. If you turn it into a router, then you can install some other software that are related to the network, like firewall. One of these is pfSense, and one of these is OpenSense. They're both a fork of the same firewall route. And with that, you can do some pretty amazing stuff. For example, you can geo-block connections to and out of your network via IP reputation, and there is a software called PF Blocker that can do that. So you can specify the policy, say never go to the addresses in country X, Y, and Z. So when they hack some of the stuff you have, they cannot attack some other countries, or the attacker cannot come from those countries. Another is DNS. This is much easier. You can just use some of the free available DNS solutions that are automatically implementing and dropping packets for the known attacker. So, for example, we know that XYZ.XYZ is an attacker. DNS will not allow you to go there. So if any of your devices is infected, it will be automatically packets to this domain or IP address will be blocked. Another solution is Snort or Suricata. This is IPS and IDS solution that are both open source and do fantastic, even in production environments and in big companies they are used. Snort is developed by Cisco, so this is their open source project, and it works very well. What it does is actually inspect the packets that are coming in, going out, and you can say, you can download the rules, apply the rules, install the software, and they will see if there's some kind of attacks is happening. If someone is trying to abuse SQL on your network, so trying SQL and attacks and stuff, other stuff like that, Snort can recognize those attacks based on their rules for the packets on the network coming in and out and drop them. Allows also, we talked about separation of networks. This separation can be done by firewall or VLANs. Sorry. So basically, you can set up two different Wi-Fi networks for one group of device and another. Most of the routers that you have from ISP can set up two Wi-Fi networks. So one for you, one for your home, and like second is guest Wi-Fi. And when guests come to your network, you give them this isolated guest Wi-Fi, not to interact with your own. But with the open source software, mainly PFS and also OpenWRT can do that. You can set up as many as 8, for example. In newer devices, you can set up 8 different Wi-Fi networks on your network, and separate those devices based on trust, based on how secure you think they are, and stuff like that. And this also prevents spread of infection when it happens. This is very very good. Quality of service is another good way to thwart attacks, so to say. So once you have IoT in your home, when attackers compromise it, they will try to attack some other websites, and that will generate a lot of traffic. So you can, with QoS, you can limit how much each device on network can use bandwidth. So if you can monitor it for a couple of days and see that your, I don't know, fridge use 1 megabyte of data per day. You can set that limit for each device or each network that you separate. And you can use some other open source project like Pi-hole. This is now well known and well tested. You can use any Raspberry Pi and turn it into a secure DNS. Basically having your own alternatives to those services that you can use for free if you want. There are some other projects that are used not specifically for IoT, but that they have IoT application as well for detecting suspicious activity. I don't know how to pronounce this, so I'll leave it to you. But it can map the data, and you can see what device communicates with what. So this can be useful to see not just devices that are communicating with each other, but the volume as well. And based on that, you can find attackers if they're on your network. Something suspicious is happening. Basically, all three of those projects are based on gathering information about network activities and analyzing it and presenting it in a graphical way so you can visually see what's happening. And the last thing is this remote attestation. This means that once you set up your first time you turn on your IoT device, you can install this Keylime. Keylime is a software that will check if the firmware and software installed on IoT device changes. So every time it reboots, it will check for the known good configuration and compare it to the ones that it first time scans. So what this prevents, for example, a hacker can, if they hack your device, not just change your password, but they can maybe upload some other firmware on it that they developed or stuff like that to give them persistence on your device. So when you turn it on and off, they will probably off your device. But they can install something to be persistence on it, even if you turn it on and off again. So this Keylime will check each time the device boots if there is any changes in software installed and configuration. And if there is a change compared to the last known good configuration, you can specify action. Action can be isolate device or don't let it run, turn it off, whatever. So this can be detection and prevention measure for IoT. I think that's all. I can show you my network. This is how I secure my network with lots of routers and stuff. But it doesn't have to be this complicated for you, because you can use Wi-Fi networks for most of it. And I'll also invite everyone who has some ideas in security, especially in IoT to talk to me.